Okay, so this is Forces video number 4, and it's all to do with stopping distance. So here we've got a vehicle, a car, and it's travelling at 30 miles per hour. And what's happened is something has changed outside of the car. So for example, a football's running along the road and a kid's chasing after it. And when you're moving at 30 miles per hour in the car, on average, it takes 23 meters for the car to stop. It's called the car's stopping distance. Now, stopping distance is made up of thinking distance and the braking distance. So if the stopping distance of a car travelling at 30 miles per hour is 23 meters, the first 9 meters is taken up by something called the thinking distance. Now, the thinking distance is the distance that the car travels during the driver's reaction time. And a driver's reaction time is usually between 0.2 and 0.9 seconds. So when that ball first goes out into the road and a child is running after it, you can't do anything about the fact that it takes you between 0.2 and 0.9 seconds to just react to that environment, okay, that change in your environment. And then we have the rest of the 23 meters. So if the first 9 meters is thinking distance, then the rest is 14 meters, because 14 plus 9 goes to 23. And that 14 meters is taken up as the braking distance. Now, this is the distance traveled by the car under the braking force. This is after you have reacted to the environment. You put your foot on the brake pedal, and that causes the car to stop. So 14 meters is taken up by the braking distance. Okay. Now, both of these things are affected by the speed of the vehicle. Of course they are, right? So if the car was travelling, if the velocity of the car was 10 miles per hour, the thinking distance and the braking distance will both be smaller because of the fact that the car is going slower. Whereas if the car is travelling at 70 miles per hour, both the thinking distance and the braking distance will be larger due to the fact that the car is travelling faster. Okay, but if we just take thinking distance on its own, now a driver's reaction time can be affected by a number of things, and here's the list of 4 that you need to know for your exam. So a driver's reaction time can be affected by tiredness, that can decrease it, drugs, so under the influence of recreational drugs, that can increase or decrease reaction time. Alcohol, generally that increases the driver's reaction time. And then distractions in and out of the vehicle. So we're thinking about looking at a cat up a tree, all the way down to using your sat-nav. That is still going to affect the driver's reaction time if they're not concentrating carefully on the road. And then over here we have braking distance. Now, braking distance can be affected by the following things, and this is not to do with the driver anymore. It's nothing to do with reaction time. This is to do with things that are going to affect the car, in particular this braking force applied from the brakes on the wheels. So, for example, wet roads and icy roads, poor brakes and poor tyres, poor condition of those two things, they're going to affect the braking distance, right? They're all going to increase the braking distance here. Now, I thought I'd link the last part of this video, I'd link it into velocity time graphs. So you learned that velocity time graphs is where you have velocity on the y-axis and you have time on the x-axis, and they tell the story of what the vehicle's doing. So if we think about this scenario at the top here, or actually it's kind of like a different scenario really, this car's travelling a little bit faster. So here we've got a car travelling at 10 meters per second. And there's obviously a change in its environment, a cat's run out into the road, and the car needs to stop. So if that's the case, there is this thinking distance. Now, obviously, during that time, you haven't got your foot on the brake, so the car's not doing anything. The car is still moving at a constant speed. Now, what you can do is that first section where it's a rectangle, that is the thinking distance of the vehicle. Okay, that is the distance that the vehicle travels during the reaction time. And remember, to calculate the distance from a velocity time graph, you do the area of that part. So the thinking distance would be 10, the height, times the width, which is 2, which is 20 meters. And then at this point here, the driver has applied the brakes. So the driver has applied the brakes. And what we end up with is we see the velocity constantly decreases to 0. So velocity becomes 0, that's where it's at rest. And the area of this triangle will be the braking distance. So braking distance, so the area of a triangle is a half times the base, which is 2 up to 6, that's 4. So half times the base times the height. Well, half times 4 is 2, 2 times 10 is 20. So the overall if that's the braking distance and that's the thinking distance, the overall stopping distance of this vehicle is 40 meters. Final thing really is this part here, and it's to just remember that the reason why a vehicle stops is due to the frictional force between the wheel and the brakes. So here's the wheel, here's the brake pads, okay, and that reduces the kinetic energy of the wheels and increases the thermal energy of the brakes, and that's the reason why the brakes become very hot. A final top tip is the fact that what a lot of students often say is that thinking distance is how long the car travels during the reaction time. Can we please say how far the distance travelled? How long can mean distance, or it can mean time. So to stop the examiner having to guess what you actually mean, thinking distance, braking distance is the distance travelled. It's not how long. You have to be really clear in your paper 2 physics exam.